Enzymes are catalysts. They catalyze biochemical reactions, speeding them up several million times by reducing their activation energy. Catalysts are not used up in the reaction. When two substrates are joined, substrate molecules bind to the active site of the enzyme, catalyzing the reaction, and the enzyme helps to form a bond between them. Without an enzyme, this reaction rarely occurs, as substrates have to collide in a certain spatial formation with a large amount of energy. When a substrate molecule is broken down, it binds to the active site of the enzyme protein. The enzyme breaks down the substrate. The strong covalent bond is rarely broken spontaneously. Enzymes are needed to speed up the reaction. The key to the regulation of the enzyme mechanism is enzyme inhibition. One type of inhibition involves an inhibitor binding to the active site. That is, it competes with the substrate. This is called competitive inhibition. Another type of inhibition is allosteric inhibition. The inhibitor binds to the allosteric inhibitor site, which causes a conformational change in the active site, preventing it from binding the substrate. Allosteric activation is the opposite of allosteric inhibition. In its default state, without an activator, the enzyme is inactive. When an activator binds to the allosteric activation site, this changes the spatial structure of the active site, enabling it to bind the substrates and catalyze the reaction. Coenzymes are molecules that transform during the enzyme reaction. They either release or accept certain substances. When the reaction is complete, the coenzyme becomes detached. Important coenzymes include NADH, NADPH, acetyl-CoA, FADH2, ATP, and vitamins.